Okay, you might be saying to yourself, Mr. Dillon, why all the angles? Can't we move on to something a little bit different? Segment lengths, maybe? Well, guess what? Yeah, that's a great idea. Let's go to segment lengths. How about we talk about two secant lines intersecting in a circle? And let's draw it something like this. Again, I'm trying to draw it not through the center, just for clarity, because it doesn't have to go through the center. It'll still work if it does. And then let's label these segments. You notice there's 4 segment pieces here, right? So let's label this piece, we'll call that A, and then I'll call this other one B, and then I'll call this C, and I'll call this D. Now, what's the relationship here? Well, there's another nice proof that we could do. Again, I'm not going to go deep into the proofs here, but if we were to make these into triangles, guess what we would know about these 2 triangles? These angles are the same. These 2 angles intercept the same arc, so they would be the same. So these triangles are similar. Haha, pretty cool, right? Yeah, I think so too. So what we could do is we could set up a proportion, and we could say that A over B equals, what do you think? C over D. Pretty cool, right? And if you could write this, if you cross multiplied, AD, A times D equals B times C. So either way. And then the next scenario, we're going to have 2 secants intersecting outside of the circle. And there we go. And again, there's 4 segments, right? 1, 2, 3, 4. Well, technically there's 6 if you consider the whole segments as well. And that actually will be important. Let me label these W, X, this is Y, this is Z. And again, if we were to do some similar triangles, let's say with this triangle here, that big one, and it would actually be similar to this, let me see if I can roughly draw it, this big triangle over here. And so we could set up another proportion, and that proportion would be W over Y equals, now we're going to move to the whole entire segment, Y plus Z over W plus X. Pretty cool. And if we were to cross multiply again, we could also write this as W times W plus X equals Y times Y plus Z. It's really your preference, whichever one is easier to work with. And the last scenario here for the segment lengths is going to be, it's going to be a tangent line. I shouldn't have drawn that too far, because we're going to stop at the point of tangency. A tangent line and a secant line intersecting outside of a circle. And let's call this T. And then this segment out here, we'll call that Y. And then we'll call this segment inside here Z. And using a similar argument with these similar triangles, get it? Similar argument, similar triangles, cool. We could get this, T squared equals Y, the outer segment, times the whole segment, Y plus Z. Okay? Maybe you can see sort of a pattern, or these mirror each other somewhat. Well, let's jump down here to problem 1, and let's apply some of these theorems. So down here we've got 2 secant lines intersecting outside of a circle, and they give us that this is 6 and 8, and then 7 and y. So we'll go ahead and apply this theorem right here, the second one, the second segment lengths theorem. And we could do this. I think I'm going to use this format. I think that one's going to be a little bit easier. So this will be our w, this will be our x, and then, but then this is y. But okay, don't get so confused. Hopefully that's not too off-putting. All right, so we would have 6, the outer segment, times the whole segment. The whole segment is 6 plus 8. And that would be equal to 7, the outer segment, times the whole segment, which would be 7 plus y. And then it's just some simple arithmetic from here. So this is 14. 6 times 14 is 84. Distribute our 7 over here. You get 49 plus 7y. And then if you subtract, you get 7y equals 35. Y equals 5. Cool. All right, and now let's go to this next one where you've got a tangent and a secant. That's going to mirror this situation. Now it's the tangent segment squared. So this is our tangent segment. That's going to be z squared equals the outer segment here times the whole piece. So 8 plus 16. Okay? So we've got z squared equals, this is 24. 8 times 24 is 192. And then if you square root that, it simplifies to 8 root 3, which is approximately 13.9. So either one of those answers would be okay for now. Okay, so let's do a little bit more here. Let's go to the next page, and let's go back to the angle measures. Let's do some angle measure problems. We didn't get to do any problems with these yet, and I wouldn't want to shortchange you. And actually, if you want to try some of these on your own, that might not be a bad idea to pause and do that. But I'll go ahead and jump in. So let's look at this first one. What is this scenario? It's two tangents. So we're going to, and it's intersecting outside of the circle. So remember, back here, all three of these scenarios where you're intersecting outside of a circle, you just subtract your arcs and take 1/2. Okay? So let's do that. We're going to set up an equation. So it's this angle, 70, equals 1/2. And now this arc is 110. This arc out here is W. So we'll do W minus 110. Cool. And to solve this, I like to get rid of that 1/2. I don't want to distribute that 1/2. Instead, I'm going to multiply both sides by 2. So that 1/2 is gone. And we're going to have 140 equals W minus 110. So then W equals 250. Nice. And then this next one, we've got the outer arc is 110. This is 2 secants. The inner arc is 30. And then this is y. So y is going to be equal 1/2 110 minus 30. So that's 1/2 of just 80, I think, right? Yeah. So 1/2 of 80. So y equals 40. How nice. And then this last one, this is 2 secants intersecting in the circle. So if you'll remember, that's like this scenario right here, where you take 1/2 of the sum of the angles. Here, when you're inside the circle, we're going to add up these arcs. So this arc plus this arc, and it's 1/2 of that. 1/2 of, 1/2 of 30 plus x. That's what 35 equals. and then use the same process. 7, multiply both sides by 2. 70 equals 30 plus x. So x equals 40. Great. All right. So here's what I want you to do. I want you to do these practice problems on your own. This first one should be straightforward. The second one, you're going to have an extra layer of work to do. And then I also want you to do problem 2 on your own. And I'll just give you a hint on problem 2. And that hint will be down here. This hopefully looks familiar as 2 tangents intersecting outside of the circle. And they don't give you any other information. They tell you this angle is 17.5, but they don't tell you anything else. Well, how about this? Let's call this angle right here, or this arc, I should say, let's call that x. So the measure of arc AB is x. Well, to help you, think about what would the measure of arc AEB be? AEB be? Especially in terms of x, right? The whole thing is 360. 360 minus x, maybe? Okay, give it a shot. All right. Good luck, everybody, and I will see you soon, and Wakanda forever.